Hey everybody, welcome back. So what we're going to do now is go over some of the various restrictions and rules about our various connections. Now, I've got them all on the screen so that you can obviously read through them ahead. Basically, the idea here is what the server has to respect from the handshaking process. All right, so I've got a handful of them here for you, and let's walk through them. So if we send a, let's get that off screen. I'm gonna be that person. I've already been it too much so far. Um, Let's say that a connection close header is sent, meaning that we have severed our connection. All right, so this is typically going to be from the client side. Server should really avoid doing this, and we'll get to that in a moment. So client sends a connection close, meaning that we close this persistent connection. We can't send any more requests on that connection because it's closed. We have closed the pipeline. Okay, the server doesn't have to respond anymore. And if we want the server to respond again, we have to open up a new connection. Just one of the restrictions. Okay, let's say the client's done. We send a connection close. That tells the server that the connection is done. All right. Other thing, the connection is going to stay persistent, meaning that this pipeline is open only if all messages are correct and have the correct self-defined length. So this is one of those nice little checks that we could put in where I am sending, some sort of a message, right? Whether it's an HTML document for upload, whether it's a request for information. Basically, if we start seeing mismatches between message length and body, then we're going to basically violate the principles here. We can sever the connection. Okay, something's going wrong. Let's just stop this connection right now, right? Other things. If we have proxies where basically maybe we are routing traffic, in some way, shape, or form, right? There's a lot of different ways we can talk about proxies. I've got a nice visual here for one of them where client talks to a server, and that basically acts as kind of a router to whichever server is hosting the actual content. One way to set up a proxy. Good classic internet joke here. Basically, if we have connections and we have a proxy in the mix, the connections have to be maintained separately. All right, so if we have proxies in the loop. They have to maintain that. Um, and if we have a response that is going on, the client actually needs to be ready to retry it. So if we, basically the issue is that if we make a request to the proxy then routes that elsewhere. The client sometimes may not receive the full packet. They have to be ready to ask for the packet again if they don't receive it. Otherwise, it's possible we get some jumbled up information, we get the incorrect message length, number of packets, things of that nature. Basically, bad things can happen. Proxying kind of becomes its own thing in a way. All right. Other rules slash regulations slash restrictions. All right, so we should have at most two connections to a server or proxy. So basically, think of this like I have a browser and I'm talking to a server. I should only have two connections to that server. And this is really intended for preventing the server from becoming overloaded. It's generally, depending on the server configuration, every connection could be a separate process on your server. Very easy to spin up hundreds and hundreds of processes. Server gets overloaded, doesn't respond anymore. You have to reboot it or somehow kill the process for the server. So basically limit processing power. And how would you get more than one connection? Well, you probably have a web application or something like that where you're making multiple requests. Maybe you want separate pipelines to keep the pathways clean or something like that. Basically, it is possible to open up more than one connection, but at most two. All right. Other things to care about here. Let's see. That one's fine. Basically, the other one is that the big one is that the server shouldn't be the one trying to close the connection. We should leave it up to the client to try and close things. Now, if the server is having issues, the server needs to go down. Maybe it's having issues fulfilling a request. Send a response back to the client to let them know something's wrong, then close the connection. Right? Maybe respond with an error forbidden. Our transaction is now complete or something of that nature. Basically let the client know what's going on. You don't want the client hanging there forever. Okay, so some rules and regs for you there. Now, again, probably going to be happening mostly under the hood. This is handled by Apache and your browsers already. So there's not a whole lot of deep dive that we need to do in there unless you want to build your own browser or your own web software or start do a deep tweak of Apache. Let's talk about actually resolving that address. Now, there are multiple ways and multiple things to consider here. This can involve finding a server. It can involve finding the resource on that server. Now, this picture I've got here is actually a nice little, it's actually a cybersecurity slide for doing a um, man-in-the-middle attack here. Basically, we have a server pretending to be another server. Not a great thing. But the idea with address resolution is we get into a network, we need to find the server, find the resource. All right, so here we have a router. Here we have two computers. We have our interloper. Again, contrived example for this one. Basically, the important thing is figuring out what is the IP address of the server that you're trying to access. This could be handled through proxying, right? So we have this where we know that our network is here. This server knows which other server to route to. Or we have a direct access to it through IP address. Once we get to that server, again, we talked about this last time, and I'll have another visual for you in a moment. How do we find the file on that particular server? Also, other issues. Is this content static or dynamic? Meaning, is it just a .html file or an image? Or is it a PHP script, a React application, Angular, whatever type of dynamic content you have, where I'm just looking for the script, and that script is in charge of generating the content. These are all aspects with resolving the address. Okay, so with this address resolution, we're going to have a module baked into Apache or to whatever web server you're using. First things first, it's going to look at the path. Does it make sense? Does that suffix exist? Does the path exist? Can we actually access that resource? Is this request pointing elsewhere, right? Is this request pointing at something where we need to bring in another module for generating the content? If we take PHP, for example, let's say that we want to, that was weird, we want to generate a blog homepage. We've written it in PHP, okay? I need to load in the PHP module or have the PHP module exist in my memory for that to be able to print out this content. Is any kind of authentication needed? All right, we could talk about authentication in terms of application-based, where you have a login form, or maybe it's provided by the server. If you're using Microsoft CIS, you could have authentication baked in with Active Directory or with your groups or your username. Similar ideas apply to Linux-based servers. Are you part of a particular group? Does your user have particular privileges? There's a lot of different things that can go into this. Again, this is all handled nicely by your web server. Okay, the other aspect is going to be how do we handle the content? So I mentioned static or dynamic. Well, if it's static, we're pointing at a particular file on your server. This is going to be relative to your document root. What's your document root, you might ask? Well, that's going to be wherever the web directory is on your server. If it's Apache, again, it's /var/www/html. If it's Microsoft IIS, it's going to be in C:/inetpub/ C:/inetpub/www root, I think, or wherever you've set it to be. All right, you can tweak these things as you need. Does it exist? Can we pull it up and send a response with the appropriate header, with the appropriate body? Or it's dynamic. Okay, well, instead of returning a particular file or some sort of an object, we have to return some sort of a dynamically generated object. Okay, is it going to be CGI or SSI? Common Gateway Interface, server-side includes. Depends on your server configuration. Regardless, we're still sending an HTTP response that looks just like any other content, but it's dynamically created. So with dynamic content generation from a server perspective, CGI versus SSI, CGI tends to be more common, honestly. This is where we are going to get a new process for every request, or we're going to have a nice pool of requests. Again, it depends if it's Apache or Microsoft or any of these other ones, however they handle process spawning. But kind of the rule of thumb is every time you make a request, there's probably a new thread spawning off or a new process spawning. Servers can only handle a set number of processes before they go sideways. Anyway, SSI is going to be, it's fairly deprecated, honestly, these days, at least to me, but it's going to look like a special HTTP comment. So this is your standard comment, um, left arrow, exclamation dash dash, and then anything inside is usually a comment. You can configure your server to accept SSI. This would be like if you want to include other HTML files, or try to be cute about templating or something like that. At least to me, these have fallen by the wayside. I'm sure there's a lot of people still using them. It's still something you can configure as well, but I haven't seen it as often myself. Don't let that stop you from using it if you can. Other ways we can generate content. So this is going to be your more common, well-known ways. So we can use templating languages. So let's take our logic, which is going to be PHP, .NET, Perl, any of these kind of dynamic web languages, and inject HTML. So this is a fairly ugly way to do it. Let's just include it directly in the page. You've seen me use the PHP tags before. Here we're just injecting something into a paragraph tag, right? I could have an entire set of pages that are only PHP generating content. If you've ever dug into WordPress, for instance, that's all PHP and setting up content and templates and configurations and all kinds of different things. It gets very, very messy at times. But the idea here is it's all generated content. Actually, not just for funsies. Let's take a look at my homepage, as I mentioned before that it's WordPress. Okay, this is all dynamically generated. This content is in a database. This content's in a database. This image is basically referenced from a database. Okay, there's a template here for my homepage. Content's all being injected at runtime in here. Nice and responsive and all that kind of fun stuff, but that's handled by my templating engine. All right, so it's injecting it. If you're going the servlet route, you're probably using Java to do that as well. Again, basically the idea is it's being dynamically generated. Alrighty, we've got, let's see, we're pretty much done. This one will just go a little bit longer. Virtual hosting mentioned before as well. That's where you have one IP address for multiple domains. Your server can configure this to say accept any number of connections for one IP address, and just based on what that domain name is, it will route you to different folders. Again, this is easy to do with Apache. I didn't make you do it, but it's absolutely feasible to do. Your server is basically just going to look at whatever request is coming in. And this is going to be basically also baked into your headers as well. But here is one example for how we handle this. So basically we have two clients here. This one's requesting example.com. This one's requesting company.com. They both talk to the same server on port 80. Just this one is sending in this request as the header. This request is the header. The server will figure out which way to route you on the file system. Again, in this case, these three domains all point to the server. They're just referenced in different folders. Honestly, what you'll probably see is that if the server is running Apache, it's probably /var/www/html/example/test/company. And the server just points you based on where you need to go. Here's another example of that as well. So here we have a server, 192.168.10.100, exists somewhere. And we have Bob's blog and Alice's blog. They both point to the exact same IP address. Difference is going to be in the host name, which is, again, just the URL put into the host header here. All right. And the way this looks from a file system perspective, /var/www, we could have /bob/alice in there. You could put it in /html. It just depends on how you configure. I guess I probably misspoke. Usually, if you are configuring subdomains, you would put it in the www directory. So ignore the previous comment. But the idea hopefully makes sense. We are just pointing at different areas of the file system. All this really is a configuration file in Apache. That's all it is. All right, so enough of the specifics. Let's talk some of the web servers out there. Apache is one that I've been slinging around quite a bit. It's very, very common. It's open source. It's free. It's easy to use. It's one of the most common servers on the web. All right. In this case, I think 2021, 35% of all websites use Apache, which is a pretty big chunk, right? But so this is funny. So this image is a little pixelated because I had a really hard time finding a good overview of their architecture for some reason. Basically, this is the architecture for Apache. So at the bottom layer, we have the operating system, typically Linux, right? I think you can get it to work on Windows or I think of other server environments, like a Red Hat or something like that, which is still Linux. But basically, the idea is that Apache is going to operate a layer above that. Now you have the Apache kernel, you have some libraries for basically getting it to run, talk to the operating system, things of that nature, and your basic HTTP core. So this is basic web transmission, basic web response request technology, right? You need this. This is what you get when you install Apache by default. You can get some extra functionality as well by installing modules. There's the aliasing module if you want to redirect things nicely. If you want to add on secure socket layer, if you want to add on Perl, if you want to add on PHP. Basically, these are all modules which a lot of them honestly can come activated by default. I don't have the list off, the top of my head, but you can easily activate them. And how do you add new ones? Well, in the first little mini lab where you set up Google Cloud in your Apache server, you did some sudo apt install PHP, sudo apt install, various components of Apache. All it was installing software. All right, so these are going to be baked into Apache once you install them. They're basically modules that live on top. You can also install other modules as well. So if I want to add on OpenSSL, I'm going to probably need the the SSL module for Apache to get them to talk, but it's very easy to install. They stack nicely. And if you want to see what your system is actually running, clear some of this old stuff out. I can say run sudo or just Apache to control ctl-m. Here's all the modules that are currently loaded into my Apache setup. All right, so we see PHP 7. We see filtering environments, deflate, index, authentication basic, Unix module, HTTP module. All of these things are enabled, and some of them we added afterwards, like this PHP 7 module. One point of note, if you're running into issues, let's say you wanted to add other modules, you need to make sure that you restart Apache, otherwise it won't know they're there. So for instance, when we installed PHP 7, we had to restart Apache, or at least we should have had to restart Apache. So this is one that we're going to get nice and comfortable with throughout the semester. There's also IIS, which is Microsoft's web server, very commonly used in industry environments. So if you're a company, you're probably running IIS because you've paid for all the Microsoft virtualization options already. Why not use IIS because you already have a license for it? It's fine. There's nothing wrong with it. It's just you have to be in the Microsoft environment to really appreciate it. Plays very nicely with Active Directory, plays very nicely with pretty much everything enterprise related that you could want. Works similarly to Apache in that you have modules. Instead of splitting off processes, we have application pools with processes inside there. Instead of websites, basically you're going to define like web applications, and configuring IIS can get very, very messy and annoying, honestly, but it works fine, right? It's a nice thing if you want to use it. Other than that, we have other servers out there as well, which you can feel free to use. There's Nginx. This is a very common one out there. There's Flask and Light HTTPD. Don't know how to pronounce that. I think it's Light TTPD. Light TPD. Bonus content. There you go. This is a Python-based web server. So if you have a low-impact application where you want to serve something simple, Light TPD is another nice light one. Tomcat, if you want to run Java applications, there are a ton of other web servers out there as well. basically pick your favorite, but remember their entire goal is to enable serving content. So pick the one that makes the most sense for you. If you're serving websites, PHP, you're doing standard web applications, you're doing React, I mean, there's nothing wrong with Apache or Nginx. If you're in a Microsoft environment, go IIS, why not, right? If you're running an IoT application, if you're using a Raspberry Pi, if you're running a simple web server that not many people are going to access, nothing wrong with Flask, right? So basically, there's a lot of them out there. Okay, other than that, that's all we're going to go into for web servers today. Hope you all have a wonderful week, and I will see you in the next video. Bye, everybody.